7.3 through 7.5 are all dealing with something called rational expressions. And probably the simplest kind of rational expressions, this is just a big fancy term for fractions. 1/2 is a rational expression. X plus 4 over 9 is a rational expression. Q squared plus 4Q plus 4 over Q to the third plus 22Q squared plus 40Q is a rational expression. So they vary in difficulty. What we are going to do is be today simplifying rational expressions. Now, in order to simplify something like this, I need to know how to simplify something like this. And I need to know how to simplify something like this. I need to work with the simpler rational expressions, and that's what's going to build us up to working with the more complicated rational expressions. So if I gave you the problem 3 plus 7 divided by 7, I would say the golden question, do I just get to cancel these 7s? Does this just equal 3? Well, no. 3 plus 7 is 10, and 10 divided by 7 definitely does not equal 3. So I have to add first and then divide. It's 10/7, honestly, would be the final answer, is fine. Now, when I have 3 times 7 divided by 7, that's a different story. Because, 3 times 7 is 21, so I can take 21 over 7. But you wouldn't leave 21 over 7. You would simplify it to be 3. So the 7s do cancel, and I'm just left with 3. Or they reduce to be 1. Reduce to be 1 is the term that I should use. Cancel is the term that I'll probably use all of the time. But I want to just practice what can and can't I do. So notice with the addition, and I'll go ahead and say or subtraction because it's true, cannot just reduce. Only reduce factors, which means that they're getting multiplied together. And you can have quantities with addition inside of it getting multiplied together, but you have to analyze, are they factors? So am I numbering these? Yeah. Number 3, I'm going to say 4 times the quantity x minus 7 over 4. These are factors. This is the factor 4 getting multiplied by the factor x minus 7. So the 4's can cancel and I get x minus 7. There's no need for me to distribute the 4 and get 4x minus 28 because both of those are divided by 4. You're left with x. And then both of those minus 7. You get the same thing. So there's no point in doing that. You can just simplify the 4's. If I have 8 times the quantity x plus 2 over 4 times the quantity x plus 2. 8 and the quantity x plus 2 are getting multiplied together. 4 and the quantity x plus 2 are getting multiplied together. So there are 2 factors in the numerator and there are 2 factors in the denominator. One of them in the numerator is 8, the other one is x plus 2. In the denominator, we've got 4 and we've got x plus 2. So the quantity x plus 2's can reduce, because if I were plugging in a number for there, say x was equal to 4, well that's 6 and that's 6. So I'm not told that x is 4, I'm just saying what if it was. I can cancel those. And then 8 over 4, I can also reduce that. 8 divided by 4 is 2 over 1. So the answer is 2. So this complicated polynomial simplified to be 2. So we just get progressively more difficult along the way. So let's see. Before we get into this problem, we'll do this problem first. We get 3k squared plus 10k divided by 10k. Now, if you remember from this problem, the 7's don't just cancel. So because of this addition, the 10k's don't just cancel. So it could be that this is simplified. But I need to be looking at the numerator as factors. So there are a lot of different factoring strategies that you've learned. One of the different factoring strategies that you've learned is GCF. So look in that numerator and tell me what the greatest common factor is between 3k squared and 10k. Well, they both have a k in them. When I factor out the k, in the first term, k squared just means k times k. So if one of the k's gets factored out, in the first term I'm left with 3k. In the second term, I'm going to factor out the k, so I'm left with plus 10. In the denominator, I'm left with 10k. So now I'm looking at factors. The numerator has two factors, k and 3k plus 10. And what I need to recognize is that the denominator has two factors as well, 10 and k. So this 10 up here is stuck in this term. If I'm going to be able to cancel that 10, I have to be able to cancel the entire quantity 3k plus 10. And since I can't do that, I can't cancel the 10s. But this k is a factor by itself, and this k is a factor by itself. So I am allowed to reduce those. So this becomes 3k plus 10 over 10. And those 10s do not cancel out because of that addition. Regardless of how much you want them to cancel, they don't. Plug in a number from k and see what they're right. And see that it's true. If you're trying to say that this is equal to 3k, plug in a number for k to see that you're wrong. I'll pick a number that's easy. I'll pick 1. When I plug in 1, 3 times 1 plus 10 divided by 10. Well, 3 times 1 is 3 plus 10 is 13 divided by 10. So if you're saying those 10s cancel out, then you're saying that this is equal to 3 times 1. So is 13 tenths equal to 3? No, of course not. So those 10s don't cancel. Okay, the next problem. We'll do this one. We'll do this next problem. I understand it might have been a while since you're factoring. So we are going to do some practice with just factoring and then in the context of a rational expression, but we'll kind of keep them separate still. So number 6 says j squared minus 5j plus 6 divided by j minus 2. When I look at this right now, I don't have factors, I have terms. So none of those j's cancel out. The 2 and the 6 don't cancel out. I can't do any of that right now. I need to factor the numerator and the denominator if it's possible. Sometimes it's not always possible. And so when you look at that numerator, this is, it's just kind of basic foiling. I've heard it called, or basic factoring. I've heard it called reverse FOIL. I'm trying to factor j squared minus 5j plus 6. So I'm looking for two numbers that multiply to be 6 and add up to be negative 5. So two numbers that multiply to be 6 and add up to be negative 5. If they multiply to be a positive 6, they both have to be negative. So the only two that do that is j minus 2 and j minus 3. Now this denominator might have been a good indicator of which direction to take because the denominator is j minus 2. Whether I put parentheses around it or not, there is only one factor in the denominator. It's j minus 2. The numerator has two factors, j minus 2 and j minus 3. So the factors j minus 2 reduce to be 1. So this problem, number 6, reduces to be j minus 3. If you plugged in a number, so say j equals 1. Notice how they don't tell me j. So this is the answer. Don't get that messed up. This is what you're typing in. This is what I'm looking for. But if j was equal to 1, then if you plugged in 1 into this quantity, you would get negative 2. How do I know that? Because when you plug it in over here, you get negative 2. But this is the answer that you're looking to get, is that it simplifies to be j minus 3. They don't tell you what j equals. Okay, number 7. Before we do number 7, let's practice some factoring strategies. So let's say I asked you to factor 8u to the third minus 2u squared. So hopefully we recognize that there are some things in common in both of these terms. They both have, between 8 and 2, they both have a 2 in common, and then if u to the third is u times u times u, and u squared is u times u, then I can factor out two of them. I can factor out the u squared. So in the first term, I'm left with 4u, and in the second term, everything canceled out or divided out, reduced to be 1. So I've got 2u squared times the quantity 4u minus 1. Let's say that this was the case. Let's say that it was 8u to the fourth minus 2u squared. So this time, they still have the same GCF 2u squared. In the first term, I'm left with 4u squared, because if there's 4 total and I only took out 2, I'm left with 4u squared. And then they still cancel out, and so it's minus 1. This is not done, and that's going to be an important thing to recognize with this, is that this can keep going. When you look in this quantity, this is called the difference of perfect squares. And off the top of my head, I think we've done this before, maybe back when we were working with polynomials and quadratics. So 4u squared. 4u squared is a perfect square. It's 2u times 2u. And 1 is a perfect squared. It's 1 times 1. So 4u squared simplifies to be 2u plus 1 times 2u minus 1. So that is called the difference of perfect squares, which is a formula that you might have to look up or reference in your book separately. But you might have multiple steps of factoring to do. So the second, or I don't even know, the fifth, I don't know how many factoring strategies I've taught you. This 5u squared minus 9u plus 4. So it's a little bit more complicated than this j term, where this is just a 1j squared, because I could guess and check, but I'm going to talk to you about something called the AC method. And I'm going to brush through it here. Maybe you can watch the video multiple times to help it make sense. But I'm going to do the AC method, which is I'm going to label the number in front of the squared term A, this B, this C. It's the same as with your quadratic formula. So I'm going to take A times C, which in this case is 5 times 4. And obviously that's 20, or maybe not so obviously, but it is 20. So I'm looking for two numbers that multiply to be 20 that add up to be negative 9. So multiply to be positive 20, add to negative 9. So negative 1 and negative 20, negative 2 and negative 10. You might not need to show all your work to find that it's negative 5 and negative 4. So this is what the AC method says. It says that instead of writing this as u minus 5, u minus 4, this is how I'm splitting up this middle term. So I'm going to rewrite negative 9u, as having two terms, negative 5u minus 4u. And that comes from these two terms here. And then I'm going to bring down the other two. So 5u squared minus 5u minus 4u plus 4. And the reason I do this, because these could simplify. These are like terms. I'm uncombining like terms, which we don't usually do. We usually combine like terms. In this case, I'm uncombining like terms so that I can factor by grouping. Factoring by grouping is when I take the first two terms and then I take the second two terms and I factor out what they have in common. So the first two terms have in common a 5u. And when I factor out 5u, I'm left with u minus 1. Now, here's the thing about factoring by grouping. What's in the parentheses has to match exactly. So what's in the parentheses has to be u minus 1. And right now I have a negative 4u and a positive 4. And I want those signs to flip. So not only am I going to recognize that 4 is the greatest common factor, but I'm going to recognize that I can factor out a negative 4. So I'm going to factor out a negative 4, and then when I divide out a negative 4u divided by negative 4 is u, and 4 divided by negative 4 is minus 1. So then I take my factoring by grouping, I take the quantities that are the same, and I write them out front, u minus 1, and then in parentheses I write what's left over, which is 5u minus 4. So the AC method part, getting up to this blue line, is new. I actually did a whole video for my Algebra 1 students about factoring by grouping. So I guess if you look around on my channel, you can find that one. The AC method, not as much, but I'm sure there are videos about the AC method, and maybe I can post one into the Google Classroom if you need a little more practice. And so here's the next problem that we're going to do. 4w to the 4th minus 20w to the 3rd plus 16w squared. So what I'm going to recognize first and foremost is that these have something in common across the board. There's a GCF. What number goes into 4 and 20 and 16? That's 4. What goes in, or how many W's are, well, this is 4 W's. This is 3 W's. And this is 2 W's. So they all have at least 2 in common. So I can factor out a W squared. So I'm dividing by 4. So I'm actually going to erase this here so I can show you what I'm doing with the GCF. I'm factoring out, dividing out 4W squared from each term. When I do that, 4's cancel. If I have 4 W's and I take away 2, I'm left with 2, so W squared. Negative 20 minus, or divided by 4 is negative 5. If there are 3 W's and I take out 2, I'm left with W. And 16 divided by 4 is 4. Both W's got taken out, so I'm done. So this GCF 4W squared is going to be in my final answer, but I'm going to ignore it. And what looked like I might have to use the AC method because this was a number greater than 1, and I actually don't have to end up using the AC method because this is W squared. So I can split up W squared into W and W, and I can find two numbers that multiply to be 4 and add up to be negative 5. And the two numbers that multiply to be 4 and add up to be negative 5 are negative 4 and negative 1. And then I write my GCF out front, 4W squared, and that whole thing is my answer. So give me a second to check how long this video is. Okay, so I am going to keep going. I don't know, might as well keep going. It's a long video. Maybe you can take a break and come back to it. This, you're at home. Okay. So, the next numbered problem that I have is number 7. Obviously, it's more than number 7, but that's okay. Number 7 says 4h squared minus 9h divided by 6h. So I need to recognize in the numerator that I can factor. What they have in common is an h. So I'm going to take out an h, and I'm going to be left with 4h minus 9. And then when I look at the denominator, I can't really factor it anymore. It's just 6h. And so this has two factors, h and 4h minus 9. And this has two factors, h, 6, and h. So I'm going to cancel out the h's and get 4h minus 9 divided by 6. Yes, 4 and 6 have something in common, and yes, 9 and 6 have something in common. But all three of them don't have anything in common. So since 4 and 9 and 6 all don't have a common factor, this is my answer. Number 8 is a little bit different. It says 6x squared y to the 4th divided by 24 x squared y to the 4th. So this is actually just reminding us a little bit about our exponent rules. So I would say that the 6 over 24, I would treat that as one problem. And then the x's, I would treat as a separate problem. And then the y's, I would treat as a separate problem. So 6 over 24 reduces to be 1/4. And then what actually happens is that all the x's cancel and all the y's cancel, so this answer is just 1/4. And so if it had said, I don't know, 18x to the 5th, y to the 4th, z to the 3rd, over 9x to the 7th, y, z, and that's it. I would look at these all separately. I would look at 18, I would look at x's, I would look at y's, and I would look at z's, and I would treat them all separate. 18 divided by 9 is 2. X to the 5th means that I have 5 x's in the numerator and I have 7 x's in the denominator. So this is, I think 1, 2, 3, 4, 5, 6, 7. And so 5 of them cancel, but those leftover x's are going to be in the denominator. Or you would get that 5 minus 7 is -2, and you would move the negative exponent to the bottom. Y to the 4th over y to the 1st is y to the 3rd in the numerator. Z to the 3rd over z to the 1st is z squared in the numerator. So that would simplify to be 2y to the 3rd z squared over x squared. So because there's no addition, everything's just getting multiplied, or there's no subtraction, these are all factors and I can just treat them separately. So then this last problem that we're going to do on this video says q squared plus 4q plus 4 divided by q to the 3rd plus 22q squared plus 40q. And so what's different about this problem is I have factoring to do in the numerator and factoring to do in the denominator. So I'm going to treat them like two separate problems. I'm going to focus on the numerator first, and I'm going to say, how do I factor this? Well, it's a trinomial, and the a value is 1. So I can just split up that into q and q. And I need two numbers that multiply to be 2, or 4, multiply to be 4 and add up to be 4, which is q plus 2 and q plus 2. So that's the numerator. Let's use a different color here. Let's use pink. So I'm going to look in the denominator. And right now I'm not quite ready to set it up into two sets of parentheses because there is a GCF. So I can take this q that they all have in common. They all have at least one q, and I can factor it out. And when I do that, in the first term I'm left with q squared, in the second term I'm left with plus 22q, and in the third term I'm left with plus 40. Now I'm ready to continue factoring this denominator. So everything else stays the same. I've got q plus 2 and q plus 2. And in the denominator, I've got a q, and then I'm going to split up q squared plus 22q plus 40 into two quantities, q and q. If anything's going to cancel, one of the quantities has to be plus 2. But we'll see. Two numbers that multiply to be 40 and add up to 22. So your 40 would be 1 and 40, 2 and 20. 4 and 10, 5 and 8, and then I'm done, 6 and 7 don't go into it evenly. So the two numbers that multiply to be 40 and add up to be 22 are 2 and 20. So we've done all this work, we wipe the sweat from our brow, and we keep going, because what we want to recognize is that there's a factor in common that can be reduced. I can reduce q plus 2 and q plus 2. So the final answer in the numerator is q plus 2. And really, whether the parentheses are there or not don't matter when it's the only thing. It's probably not a bad habit to just leave them on there. And then in the denominator, after it canceled, I'm left with q and q plus 20. And as far as simplifying goes, I would rather you leave it like this. I don't want you to distribute the q, because if maybe we missed something and there was more simplifying to do, I would want you to recognize that. So this is the final answer. And so after doing this lesson, this video, I want you to be able to go to IXL and go to Algebra 2 level and do N4. I'm just going to write it again, N4. It's simplifying rational expressions. And then in the next video is when we're going to do multiplying and dividing. So this prepares you to do N4. All right. How'd I do? 25 minutes. Hey, we still have, 20 minutes left in class. You start your homework. All right. Bye.